In this session, we will have a discussion of Module 3 and the topic Downlink Transport Channel Processing Overview. So, we will see the block diagram of downlink transport channel. In this block diagram, there are two segmentation, that is overall block diagram process is divided into two process. One is modulation process, another one is channel coding process. By the block itself we'll come to know that the channel coding process is taking place of CRC addition, code block segmentation, channel coding, rate matching and code block concatenation. Okay, now first in this session we will discuss about only channel coding processing. So the channel coding processing is nothing but mapping the incoming transport block from MAC layer into different code word. This channel coding processing include the few procedures such as CRC addition. CRC is nothing but cyclic redundancy coding addition. The second thing is code block segmentation. The third is channel coding. Fourth, rate matching. Fifth is code block concatenation. So let us see one by one. What is CRC addition? It is a error detecting code, that is block of data entering this system will get a short check value. Okay, so that is called as cyclic redundancy check bit that will be added to the transport block which is entering into the system. Let us see. This is the CRC addition transport block. Along this block we will add one CRC, that is nothing but cyclic redundancy check. Here 24-bit CRC will added for each transport block. So in continuation of that CRC addition, in the block diagram followed by the CRC addition, the next block is the code block segmentation. Here, first we wanted to know what is code block segmentation, why we want to follow this. Actually, this code block segmentation is a generic procedure which is commonly applied before turbo encoding. So we all are aware about that. The channel coding which taken place, we will whatever the data or transport block entering into the system, we will encode it. So this is the procedure which is applied before the turbo encoding. The main function of this segmentation is fragment a large transport block into smaller code block. See the first block of this diagram, transport block along with the cyclic redundancy check bit is there. So after that is called as M block. Now we are going to break the M block into small block, that is called fragmentation. So now we see the transport block along with CRC is broke down into code block 1, code block 2 up to code block M. After the segmentation or fragmenting the entire transport block into small block, the next step is insertion of filler bit in first code block. What do you mean by insertion of filler bit? Insertion of non-information bit into the data bit. Already the transport block consists of some data bit. Along with the data bit, we are adding some or we are inserting some non-data bit. that we will sometimes we will call it as bit stuffing. Bit stuffing. After this insertion of this bit, we are going for the calculation and insertion of code. In the last third step, what we did, each and every broken block, we added a cyclic redundancy check. As already explained, that CRC is used for error detection. So we have added a CRC bit for all each and every block. Then this output is given to the channel coding. So now what do you mean by channel coding? This channel coding, it is nothing but encoder. Channel encoder applied to the transport channel is categorized into two forms. One is tail biting convolutional coding and the another one is convolutional turbo coding. Okay. So channel encoders, there are two types, that is nothing but tail biting convolutional coding and convolutional turbo coding. So followed by this channel coding, the output of this channel coding is given to the rate matching. Let us see what is rate matching. So the main task of this rate matching is to extract the exact set of bit which is to be transmitted with a given TTA. TTA is nothing but transition time interval. Already we were aware about that each transport block has a transition time interval, and in LTE the transition time interval is defined as 1 millisecond. So this is the block diagram for the rate matching. Here we can see, followed by the coding block, it has the interleaving function, bit collection function and bit selection function. So that is interleaving, bit collection, bit selection and code block concatenation. So let us see the diagrammatic representation and we will study the operation. See here, first the total thing is divided into systematic stream, then parity stream 1 and parity stream 2. The next, after this is the coded block. After this, the next step is interleaving. What do you mean by interleaving? So why we want to perform this interleaving? The interleaving is performed for each bit stream. Okay, so we clearly in the diagrammatic we can able to understand the interleaving is performed for each bit stream done by a block interleaver. And after this block interleaver has done the interleaving process, the next step is bit collection. So what do you mean by bit collection? Okay, that is nothing but by the diagrammatic representation, the downward arrow represents into the third block. From here clearly we can identify that collection of bit from the interleaved streams. Okay, we are collecting the bit from the interleaved stream. If you focus properly into the diagram, you can see for the first sub-block interleaver, the bit has been collected and it will be going for the second. So this process will create a circular buffer. Okay, circular buffer. And the last thing is bit selection. So first the collection of the particular thing over, the next is bit selection. So why you want to select the bit? Is it need of selecting the bit or randomly you can pick the bit? No, we want to select the bit because it is a output sequence bit. But before selecting the output sequence bit, first we want to determine the sequence length. This sequence length is represented as capital L. Okay, on what basis we can select the sequence length capital L? So, based on the number of allocated resources block, that is the first category, and also based on the modulation scheme. And the third category is based on the multiple input, multiple output mode. So based on these three category, we are able to select the sequence length. Okay, once we selected the sequence length, it is a efficient way to select the output sequence bit. So these all are the process taken place in the interleaver and bit collection and bit selection. Followed by this process, the next thing is code block concatenation. So what do you mean by code block concatenation? It is nothing but it need only for turbo coding when the number of code block is larger than 1.